Okay, we're back, section 4.1, but this time we're at part 2. So we left off at the law of large numbers, and now we're going to move to complement. We're actually going to cover complement over the next several sections, but we call the complement of A not A, or A with like a line over it, and we call that not A. And it consists of all the outcomes in which A does not occur. So in a recent year, there were 3 million skydiving jumps and 21 of them resulted in death. Find the probability of not dying while skydiving. So not dying, skydiving. We're still looking over the total as always our denominator and then the people that didn't die. So there, how many people didn't die? Well, it's the 3 million minus 21. How many people didn't die is 299. Okay, how many nines here? 1, 2, 3, 4, 7, 9. It gives me more hope. And then over that 3 million. And so when I calculate that, I get how many nines? 1, 2, 3, 4, 5. 2, 3, 4, 5. That is the probability of not dying. I like that number. That almost makes me want to skydive, but I can tell you with certainty that I will never have never. And I repeat, will never skydive. Go ahead and give this one a try. Careful here because it's kind of like a double negative, so just be mindful. And there you go. So identifying significant results. So the probability of a particular observed event is very small, and the observed event occurs significantly less than or significantly greater than what we typically expect. We conclude that the assumption is probably not correct. The rare event rule. The thing about probabilities is there's a lot of intuition and kind of basic understanding around it, but this is important. We're comparing this less than or equal to this probability of 0.05. We call that the significant point. So if something is significantly high or significantly low, we're looking at if that probability is less than 0.05. So again, to conclude for probability, the probability of an event is between 0 and 1, and we're not talking about percents, we're talking about the decimal fractions. The probability of an impossible event is 0. Something that is certain is 1. We use P of A for event A, and then this represents the complement, the probability of not A. So let's talk about odds. Odds against, actual odds against, we use the ratio of the probability of not A over the probability of A, and we always reduce that fraction. The actual odds in favor is the reverse, the probability of the event over the probability of not the event. And then the payoff odds against event A occurring are the ratio of the net profit, what you win, to the amount of the bet. We're going to take it one by one. If you bet $5 on the number 13 in roulette, your probability of winning is 1 over 38. But the payoff odds are given by the casino as 35 to 1. We're going to do A, B, and C, but I'm going to break it up. So A, find the actual odds against the outcome of 13. So actual odds against. The actual odds against is this ratio here. So I need to know, to find the actual odds against, I need to know the probability of not A over the probability of A. So A this time being 13. So this is the probability of not 13, and I'm breaking my rule here by putting 13 inside, and the probability of 13. So what's the probability of not getting 13? Well, they say the probability of winning is 1 over 38. Well, so I can put that there, 1 over 38. So that means it's 37 over 38 that I'm not going to get 13. So when I type that in my calculator, just do it really carefully. Type the whole numerator and then hit enter. And then when you hit divide, use a parenthesis for the denominator. You're going to end up getting 37 and make it a fraction because we want it to be a ratio here. Let's go back. It's expressed in the form A to B. Okay, so we need a denominator to express this. So 37 over 1 or 37 to 1 is the actual odds against. Okay, let's look at B. How much net profit would you make if you win by betting $5 on 13? Okay, so we're looking at the payoff odds against. So the payoff odds against, and I'll go back up to the previous slide, is the net profit to the amount of the bet. So that is equal to the net profit to the amount of the bet. Okay, so what is the odds that the casino gives? The casino gives the payoff odds as 35 to 1. So if that means that it would be $35 to every $1 bet. So if I'm doing a $5 bet, I multiply that by 5, so I multiply that by 5, and I get 175. Now, that's the net profit, okay? But how much am I actually taking home? Well, I'm going to take this home, but I also get to take back my bet, right? So they asked for net profit, but 180 would be how much I would win there in total. And let's look at C. If the casino was not operating for profit and the payoff odds were changed to match the actual odds against, which we found in 13, how much would you win if the outcome were 13? Okay, well, we know that the actual odds are 37 to 1. We found that in part A. So that would be a payoff of $37 to $1. And if I'm betting 5, that would be 185 to my $5. So my net would be here 185, or getting back my $5, 190. All right, you guys are going to give this one a try. And press play when you're ready to see the answer. And there you go. And that concludes section 4.1.